Langkah pertama adalah pergi kepada ni, copy, save dalam file. Conversion.
Assalamualaikum. My name is Muhammad Fashakir bin Muhammad Zahir. My number metric 1913925546. I will explain about question number 8. What is the length of each of the first 6 TCP segments? From this question, I have get this answer from the Wireshark at this point. TCP. Okay, for the next question, question number 9. What is the minimum amount of available buffer space advertised at the receive for the entire trace? From this question, I get that the minimum amount of available buffer space is advertised as the window size is only 1514 bytes. Yes, this is M6. Okay, we can look at this point. There are so many 1514. So I get this answer from this. Okay, for the question 10, we can look this answer from the graph at the Wireshark. You can go to statistic, TCP string graph, time sequence events. Okay, we look for a while. Okay, from this graph, as we can see, there is no retransmit segment at this graph. Okay, close back. For the next question, question number 12. What is the throughput bytes transfer per unit time for the TCP connection? Okay, from my calculation, throughput equal to amount of the data transmit over time incurred, and I get 123619 bytes. For the my first time statement send, I get 8.996799 second. Can look at Wireshark line 26. This. Okay, you can look at this. And next, for the last segment time, can look at line 384. I add this. I 18.124781 seconds. Okay, for the to find the time incurred, the last segment time equal to first time segment and get the answer. Use this answer and you can find the output. So the answer for the output is 13.543 kilobyte per second. Okay. From the last question, question number 13, it was asked use the time sequence graph plotting 2 to view the sequence number versus time. Plot all segment being sent from the client to the GICS umas.edu server. From this situation 13, I have get the answer from the graph. The slow start phase begins at about 0 and ends about 1.4 seconds in according to the graph. The question test over. We can see at this graph, it start from 0 and end about 1.4 seconds for the line 26. Okay, just that I want to okay. Thank you.
Hello, my name is Arif KG. I'll be demonstrating on the Wireshark IP for the lab assessment. So, number one is the IP address of the computer, which is the 192.168.1 and 1.102. That is the IP of the computer. That is the value of the upper protocol field. The upper protocol field is ICMP1. Next is the header, the IP head, the how many bytes are there in the IP header. So it showed here the IP header size is 20 bytes. The payload is 64 bytes because the total length of the byte, the packet is 84 bytes. So next is the IP datagram being fragmented. The answer is no, because the fragment offset is still set to 0. Number 5, which field in the IP datagram always change from one datagram to the next? So one to the next, the changes are the header checksum and the identification. So for number 6, which field stay constant, which field must stay constant, and which field must change? So the field that must stay constant is the IP version, the length of header, the IP source, the IP destination, and the upper layer protocol. The field that must stay constant is the same, which is IP version, the length of header, the IP source, IP destination, and the upper layer protocol. The field that must change is the header checksum and the identification. For the number 7, what pattern can I see for each identification? So I will show the example for number here. The IP identification increases each time. We showed here the IP identification. Each time it increased by 1. For the number 8, what is the value of identification field and the TLL? Shown here, the identification is 13008 and the TLL is 1. For the number 9, what value remain unchanged for all the ICMP TLL? The identification field changes from all the replies because of its unique value. If two identification fields have the same value, then the reply must be fragment of a bigger packet. For the TLL field does not change because the time to leave to the first hop router is always the same. For the number 10, the message has been fragmented across more than one IP, which is yes, the message has been fragmented across more than one IP datagram. For the first fragment, it will indicate that the fragment offset will be 0 and the second fragment will be the 1480. The reason why the second fragment has no more fragment because it no longer has a flag set for more fragment. For the number 13, what field changed in the IP header between the first and the second fragment? It indicates that the field that changed are the total length, the flag set, the fragment offset, and the header checksum. Next is how many fragments were created from the original datagram. So after creating the 3500 bytes, 3 fragments have been created. Finally, what field changed in the IP header among the fragment? The first fragment, the first IP header have a 1500 total length with 0 fragment offset. For the second, it only have a 548 total length and with a fragment offset of 1480. And finally, the third header have the same total length which with the first one, which is 1500 with 0 fragment. And that's all. Thank you.